Okay, so just trying to give a sense as to what we do when we're doing Euclidean algorithm. I want to give a little bit more detail on how this flow works. Okay, so I start with positive numbers, A and B. Okay, and then I'm going to divide larger by smaller. Okay, when I do that, I'm going to have a remainder. So is the remainder 0? Okay, so either it is or it isn't. If the answer is yes, then the GCD was the last divisor. If the answer was no, I'm going to divide the last divisor by the remainder. Okay. So let's take a look at something that's a lot larger than we've seen so far. Let's take a look at, so we're going to find the GCD of 10,764 and 2,300. Okay, so let's go through our little process here. What's the bigger number? So clearly we're going to take 2,300 into 10,764. Okay, and so we would play around with the numbers and hopefully, it goes in there once. Let's see, twice would be 46. 3 times would be 69. 4 times looks about right. So we'll try 4 times on that. So that's clearly a bunch of zeros, and then we get a 2, and then carry the 1. Okay, so that does actually look big enough. All right, and we get a remainder of 1564. Okay, so then I'm going to take the remainder of 1564 and divide that into the smaller number, into the 2300, and then just think how many times does that go in. So clearly once, and then I want to subtract out that, and I get, let's see, 736. I'm going to go over here. All right, so 736 goes into 1564. And let's see, it goes in there once. Double it. I'm going to try doubling it. Let's see. So that gives us 12, 6, 7, and then 14. Okay, so doubling it was a good idea. And then I'm going to subtract. That's a 2. We're going to borrow. That's a 9, so I get 92. And, okay, so remainder 92. So then I want 92 goes into 736. Oh my. Let's see, I know 10 is 920, so 9 would be 8 something, so 800, so I'd say 8 times. That's what I'm just guessing here. Alright, so that's 736. Okay, so I got a remainder of 0. Okay, so that was my goal, was to get a remainder of 0. And so what was the last number I divided in? The last number I divided in was 92. So that's my GCD. So the GCD of 10,764 and 2,300 happens to be 92. It's the biggest number that goes into both of them. All right, so another little thought experiment. We're switching gears and sort of leaving greatest common divisor to look at the other concept in this section. So here's sort of a thought problem that has a little bit of personal significance for me. Let me read it to you, and then I'll point out what I'm giggling out in the back of my mind. Hot dogs usually sold 10 to a package, while hot dog buns are sold 8 to a package. Now there's a travesty, isn't it? What's the least number of packages of each you must buy so that there's an equal number of hot dogs and buns? Okay. I personally find this funny because my wife refuses to eat a hot dog unless there's a bun. Won't even touch bread. But anyway, so the hot dog versus hot dog bun controversy is real drama for me. Okay, so the question now, the easiest way to do it is we can just say, well, just multiply the two numbers together, right? Because then I'm guaranteed it's going to work. But the question is, what's the least number that we could buy? Okay, so what I'm going to do then is I'm going to say, well, let's look at, let's make a little chart here, and we'll call it dogs versus buns. All right, so if I buy 1, then I have 10 and I have 8. If I buy 2, I got 20 and I got 16. If I got 3, I got 30, and I got 24. I got 4, I got 40 hot dogs, and then I got 32 buns. If I buy 5 of each, I have 50, and then I have 40 right there. Okay, so but wait a second, because initially it's like I could just do 8 times 10 to get it. I could buy 10 of one and 8 of another, but I found a number they have in common, and the earliest number they have in common is 40, right? So if I go out and buy 4 hot dog containers, or 4 hot dog, 4 hot dog packages, wow, containers, wow, really? And I buy 5 buns, then I know nothing's going to get wasted. Unless, of course, you have a little squished bun, and oh, I hate that. Anyway, so let's learn some terminology associated with this. Okay, so the concept that we just illustrated is something called a least common multiple. So let's put a definition on this. All right, a least common multiple of 2 non-zero whole numbers, a and b, is the least non-zero whole number that simultaneously is a multiple of a and a multiple of b. Okay, in other words, you generate the list of multiples and you look for the smallest number they have in common. There are a couple of different methods to do this, so just like everything else we've seen so far in this class, I'm going to show you that. The first method we're going to look at is called the number line method. So let's set this up. I want to find the least common multiple of, say, 3 and 4. So I'm going to make a number line. So 0, 1, 2, 3, 4, 5, 6, 7. Just going to generate this out. I'll go to, okay. And so I'm going to start with 3 here. So 3 obviously goes to 3, and then 3 goes to 6, and then 3 goes to 9, and then 3 goes to 12, and 3 goes to 15. So I'm just breaking up 15 into those 3 chunks. 4, on the other hand, and I'm going to switch colors for this. Okay, so 4 would go to 4, and then it'd go to 8, and then it'd go to 12. Now notice, right there, they both hit the same spot, right? So I would say then that the smallest multiple of 3 and 4 would happen to be 12. Okay, the color rod method is very similar to the other color rod method, only this time we're not dividing up something, we are multiplying it out. It's kind of similar to the number line if you really think about it. So what I'm going to do is I'm going to look at how many rods do I need to connect together till I get the same length. So Obviously, when I'm connecting rod length 3, and I'm sorry, I did that backwards. This is rod length 4, and that's rod length 3. I notice those two sets intersect at the same length, and when I construct that length, I have to have a rod length of 12. So that's just a little more concrete way of doing it. All right, intersection of sets is where we just make a list of the numbers and look what they have in common. So let's take a look at, say, 8 and 12. 8 and 12, so I just start making lists of multiples. So 8, 16, 24, 32, 40, 48, 56. You know, I keep going. 12, be 12, 24, 36, 48, 60. Okay, and at this point, I'm going to stop and I'm going to look for, you know, what do they have in common, if anything. And I see that they have a 24 in common, and I see that there's a 48 in common. And so obviously the least common multiple of this would be the smallest intersection. So the LCM of 8 and 12 would be 24.